Club Activated Shirt is a hands-free, sound-responsive smart apparel system tailored for high-energy environments such as cheerleaders, pep rallies, and much more. So, the problem statement for this project is static and passive apparel. So, mostly the fan merchandise or also cheerleaders outfit are mostly non-responsive and static. So this is one of the main reasons we came up with the club activated shirt, is to engage more with the audience and to make the whole thing more interesting. Next is the disconnection from crowd energy. Connecting the main point that I just stated above, the existing apparels fail to capture, reflect, or amplify the real-time patient and auditory energy of live spectators. This will decrease the energy and will make the whole event unengaging. So this is also one of the main reasons why we came up with the idea to invent or make a prototype of the club activated shirt. We have three objectives of this project, one of it being audio-visual integration by integrates microelectronics and LED strips into everyday wear. And next is synchronized group aesthetics, is to allow a group of performers such as cheerleaders to create massive unified visual patterns simultaneously driven by rhythmic clapping. Next is enhanced fan experience, transforming the traditional auditory cheering into a powerful dynamic light display that elevates the stadium atmosphere, will make the whole thing more merrier.
Now, I would like to explain the process and creation of our project, which is the club activated switch using Arduino Uno. The first step was identifying the problem and defining our project objective. We wanted to create a simple and convenient way to control a light without using a traditional switch. Therefore, we decided to develop a system that can turn a light on and off using clap sound. Next, we designed the circuit and planned how each component would work together. We selected the Arduino Uno as the main controller, the sound sensor to detect clap sound, and relay module to act as a switch. Also, and the LED light as the port of the device. After completing the design stage, we assembled that hardware by connecting all the components according to the circuit diagram. Once the connection were complete, we developed the Arduino code and upload it to the Arduino board. Finally, we carry out several testing seasons to ensure the system functioned correctly. We adjust the sensor sensitivity and check the circuit connection to improve the accuracy and performance of our project. Through this process, we successfully developed a clap-activated lighting system. This slide shows the material and technologies used in our project. The first component is the Arduino Uno, which serves as the brain of the system. It receives signal from the sound sensor, processes the information, and controls the relay module. The second component is the sound sensor module. Its function is to detect clap sound and convert them into electrical signal that can be read by the Arduino. Next is the relay module. The relay acts as an electronic switch that allows the Arduino to control the LED light safely. When a clap is detected, the relay changes its state and turns the light on or off. We also use an LED light as the output device to demonstrate the operation of the system. Jumper wire were used to connect all the components together and ensure proper communication between them. For software, we use Arduino IDE to write, edit, compile, and upload the code to the Arduino board. This software was essential for programming and testing the functionality of our project. This slide presents a sample of the Arduino code used in our project. At the beginning of the program, we define the pin number for the sound sensor and relay module. The sound sensor is connected to pin 2 while the relay module is connected to pin 8. In the setup section, the sound sensor pin is configured as an input and the relay pin as an output. The relay is initially set to the off state. Inside the loop function, the Arduino continuously reads the signal from the sound sensor. When a clap sound is detected, the sensor sends signal to the Arduino. The code then checks whether a valid clap has occurred. If a clap is detected, the relay state is toggled. This means that if the light is currently off, it will turn on, and if it's on, and it will turn off. A short delay is included in the program to prevent one clap from being detected multiple times. This improves the reliability and accuracy of the system. Overall, the code enables the Arduino to detect clap sound and automatically control the light through the relay module, making the system simple, practical, and easy to use.
Let's take a look at the final product. What you see here is a standard shirt that has been performed with the power of electronic. The core of this design is portability. The power bank, which is discreetly hidden, is the heart of the system. It supplies the necessary electrical power to the Arduino Uno, the relay module, and the LED strip. Because of this, the shirt is completely wearable and wireless, operating without needing the plug into a wall socket. This makes it perfect for events, parties, or any situation where you want to make a statement. On the front, we have high brightness LED strip attached to the fabric. When the system is activated, this LED lights up to create a bright and eye-catching visual effect that is sure to impress. Finally, the key interaction comes from the sound sensor. It's always listening, and its job is to detect the specific acoustic pattern of clap. Once detected, it sends a signal to Arduino, which then commands the relay module to act as a switch and turn the LED strips on. To really understand the intelligence behind the shirt, let's take a look at this flowchart. Step 1. The clap. The user initiates the process by clapping their hands together. This creates a sharp, distant sound wave. Step 2. The sound sensor. This is our input device. It is constantly monitoring the environment for sound. When it detects a clap, it converts the acoustic energy into an electrical signal and sends it to the brain of the operation. Step 3. The Arduino Uno. The Arduino is the microcontroller that processes the incoming signal. It's programmed to ignore random noises and only trigger when it receives a signal that matches the profile of a clap. Once verified, it sends a signal to the next component. Step 4. The relay module. This is the electronic switch. Think of it as gatekeeper. The Arduino signals is low power. When the LEDs need more power, the relay receives the Arduino signal and closes to circuit, allowing the main power from the power bank to flow to the LEDs. Step 5. The LED strips. Finally, the power reaches the LEDs and the shirt comes to life, lighting up instantly.
3. Okey lagi. 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah.
Now, I will present
about outcome for our project, which is our result. Our clap activated shirt was successfully developed and functioned as intended. The prototype is able to detect clapping sound and automatically activate the LED strip in real time. During testing, the LED responded consistently whenever clapping was detected. This proved that the integration between the sound sensor and wearable textile technology worked effectively. Overall, the project successfully achieved its objective by creating the interactive smart shirt that enhances visual effect and creates a more exciting experience for sport fans and cheerleading performance. In conclusion, our project successfully achieved its objective by combining wearable technology with sound-responsive lighting. The clap-activated shirt demonstrates how smart textile can create a more interactive and engaging experience for sport, event, and group performance. For future improvement, we plan to improve the sound detection system so it can be better discouraging clapping from background noise. We also hope to add more lighting pattern and color option, use a rechargeable battery with longer operating time, and make the electronic components detachable so the shirt can be washed safely.